All right, I think I said the last video was going to be the last one, but I lied. I decided to break this into two videos. The last thing to discuss about functions is composition of functions. In algebra, you talk about composition of functions when you do stuff like, let's say f of x equals x squared and g of x equals like x minus 3. And if you go f of g of x, right, then you're saying let's put the g of x outputs into the function f as inputs, right? And then you get like x minus 3, take that whole quantity and square it, right? So the idea is, x goes into one function, let's call it g, some function output comes out, and then that output goes into the next function, we'll call it f, and then what comes out of that is another output. So this is f of g of x. So it's essentially sticking functions together in a sequence and producing like a superfunction which is a combination of the other two functions, right? So that's function composition. Now, one of the important things about that is that whatever set this input comes from, you got a set that this input comes from. Let's say that comes from set A, all right? The output over here, that's going to come from set B, and the set that the output comes from needs to be the same as the set that the input comes from for F, right? The outputs of G need to be of the same type as the inputs for F in order for G of X to become a valid input for F. Then F of X, it gives you, outputs in possibly some other set. And now, when you compose them together, you're going to put in things from set A, and you're going to get out things from set C. I meant to write C over there. So it's going to bypass B entirely. But the outputs of G need to be valid inputs for F. So what we see here is function composition is only possible when you have a function. I kind of wrote this backwards. Sorry. Let me swap this around. Oh man, I'm not going to be able to swap it around. We're going to have to deal with it. So it's backwards. Here, the f and the g are swapped from here and to here. Sorry about that. It's only possible when your one function goes from A to B, and the other function starts with B elements and goes to C. Okay, so the codomain of the first function has to be equal to the domain of the second function. So then when you compose them, the composition is written backwards, as it is in algebra, as always. So you got like G composed with F. And that produces something that goes from the starting set all the way to the ending set, A to C. So here's how you define it. It says G composed with F evaluated at an element A is equal to C if and only if there exists some element in the middle, some element B, such that f of A is B and g of B is C. So essentially that's saying what we're used to seeing, which is g of f of A is this, g of f of A, like that. So let's wrap this up with a like an arrow diagram example. These are with finite sets, and it doesn't have to be with finite sets. You can do this with infinite sets as well, but the arrow diagram is nice because it helps us kind of see what's going on. So here we're seeing the function f mapping from A to B, and it goes like this. And in this case, it's not surjective. That's fine. This A has 3 elements and B has 4, so it's not surjective because the square is left out. But then G is a function that maps from B to C, and G takes every element of B and maps it somewhere in C. So in particular, we see the square does get mapped somewhere here. This particular part of it right here, this particular mapping, that square maps to blue, that doesn't actually end up being relevant at all when we take the composition, because nothing was mapping to square, so nothing is going to go through square to get to blue. That doesn't matter. When you take the composition, all you do is you follow the arrows through. So 1 is going to map to X, which in turn maps to red, and so therefore 1 maps to red. 2 maps to circle, which in turn maps to green, so 2 is going to map to green. 3 goes to triangle, which maps to green, so 3 is going to map to green as well. And in the composition here, nothing actually ends up mapping to blue. Even though something did map to blue in G, it doesn't end up being included in the composition. So that's basically how function composition works. I think that's all I will do for now. We'll probably discuss some more examples in class.